25 kilonewton per meter cube. The unit is here is okay, kilonewton meter per second. It should be change modulus of elasticity. The modulus of elasticity in concrete is 5000 root FCK, but in it is in mm. We should be change it into the kilonewton meter. So it is converted by 5000 into 20 to power 0.5. Now the Poisson resistance should be put 0.2. That is, it is vary from 0.7 to 0.2. No, 0.7 to 2. So it should be put here. No, 0.2. Yeah, 0.2. Okay, it is vary from 0.2. The specific concrete compressive strength FCK. That is, if you use the M20 concrete, then put here 20. Okay. Again, we should define the section properties. In frame section, in add new property. Here is we should the concrete rectangular. Generally, the rectangular shape should be provided. Section names should be provided as you want. Then the depth and here depth and width are provided in meter. That is, the standard unit is meter. Kilonewton meter centigrade means the standard dimension should be provided in the meter. So I should be provide the depth is 0.3 meter, 0.3 meter, and width should be 0.2 meter. The material should be for the ERG material. Okay. Now to assign the load, first of all, in member we should be provide this here support. To provide the support, first of all, click the left support and right click on this support. Left click and right click. Right click. Double clicking resistance. Click. Choose any type of support as you want. I want to provide the hill support. So in update display. Okay. In another end, I want to provide roller support. So left click, right click, double click resistance, provide any type of support. Roller support. Update display. Okay. Yeah, you can see the how we can insert support in the material in the member. Now it's time to assign the load. To assign the load, select main bar. That is, select main bar. Go to assign. Go to frame load. I want to assign the distributor load on the member, on the beam. That is, click on distributor load. I want to provide 10 kilonewton distributor load. So put here 10. Okay, you should be see here 10 kilonewton. Or you can see you can see left click, assign frame section, ear section. Okay, here ear section means it is already taken 10 kilonewton load in this member. Now to analyze this beam, first of all, go analyze, set analyze option. Please choose the exact planes. Exact plane. Okay. Now this project is saved as you want in your. I want to save here. And to run analysis, go analyze, run analyze. For model, here is you should change do not run option, because in the model should not be run. So you choose do not run option, and then here dead load should be run now. It takes to some few minutes, few seconds. Now you can see this type of beam it means it is bending by applying 10 kN load. If you apply the 10 kN load in the member, in the beam, then it should be, how does it should be bend is shown by this software. To show animation, click start animation, you can see the animation. That is, if we apply this type of load, then the beam should be swing into fro action. And stop animation, click stop animation. Okay, to see the bending moment and its shear force diagram, click here. Here joint frame cables. To see the shear force diagram, click shear to option and then OK. Here it is the shear force diagram of this type of beam. And to click the bending moment diagram, frame cables, moment 3 it is the bending moment diagram. If you want to see the value in the diagram, then click in joint option, go framing cable. Here option, in a from option, you can tick the show value on diagram. Okay. Similarly, you can also see the shear force diagram. Show value option, shear force diagram. Here it means when you apply the dead load, when you assume the dead load, then the value should be the 42.06 kN in one support and another support 42.86 kN. Now to see the value in different location, select this member, right click in this member, select this member, right click in this member. The values. If you want to show maximum value, then click show max. Here it is the maximum value on the support. It is the bending moment diagram. It is the resultant shear force diagram. It is in the simple support beam, the reaction, vertical reactions. If you want to see the if you want to see how much value is in 2 meters from the left support, that is you should select the IN. That is IN means the left support end, and JN means the right support end. If you want to see the 2 meter, how much value of the 2 meter from the left support, then click IN. Here you should be 2 meter. Here you can see this value. Done. At last, we can unlock this model. First of all, I want to see what is the value by don't using the self weight. For this, select the member, and then double click on the property. Select member, right click, and double click on the property modifier. Confirm OK. Cancel. First of all, unlock the model. Yes, OK. If we don't want to put the self weight of the beam, then to analyze the beam, we can select the member, right click on the member, then click on the property modifier. Then it should be fill here 0 and 0. That means mass and weight should be 0. That is mass and weight of self weight and self mass should be 0. Then okay. Now to run this analyze. Run now. Yeah. The change should be there should be change in value. That is, in first of all, when we assign the dead load, the shear force value should be 42.86. But when we don't assign the self weight, then the value should be decreased. Thank you for watching this tutorial. If you want to watch other tutorials, please log in www.ergwifi.blogspot.com. ergwifi.blogspot.com. Thank you for watching. Bye. Tata.